Hey everyone, in this video we'll continue on with the Amazon Bedrock series, and we'll specifically explore how we can integrate the different models provided by Amazon Bedrock with the popular open source framework LangChain to build powerful RAG workflows or retrieval augmented generation. And what we'll do is to start this video, we'll first conceptually understand what exactly RAG is, why is it so good in terms of enhancing or kind of augmenting your Gen AI applications to squeeze out more performance of the LLM, and we'll talk about the different kind of parts that a RAG workflow is composed of and what our technical stack that we're using is, and what are the different options that exist for you out there in the field as well. And then we'll also talk of the framework that really brings everything together, LangChain. This is a Gen AI orchestration framework that's open source, and it really helps build these RAG or even agentic and different types of Gen AI workflows. And we'll talk about what it specifically does, why it's so useful, especially in this use case. And then we'll get hands-on directly with it, where we build a bit of a sample RAG prototype where we can see Bedrock and LangChain integrated together. So with that being said, I'll hop directly into the whiteboard itself and walk through some of these concepts before we can get to the code. So RAG, or retrieval augmented generation, as I kind of spelled out there, why is it so beneficial with augmenting LLMs or enhancing their performance? And the way I like to think of it, or the analogy I give whenever people ask me here, is it's a bit of a study guide almost. So imagine that you're a student that has an exam coming up. Would you perform better if you had a open notes exam versus just completely going off your own memory, no notes, no study guide, no nothing, right? And no matter how smart you are, whenever you have access to all that additional information or kind of study guides or notes, that really helps you kind of answer any questions you might see on the exam that you might not have stored within your memory or your brain. And this is similar, obviously, a high level kind of view of how the LLM itself is. In the fact that LLMs are really, really powerful, they've been trained on an enormous amount of data, but there's still some data they don't have access to. And if there's questions that are asked around those documents or corpus, then it's not going to be able to answer it because it doesn't have knowledge of it. So very similar to that exam analogy where maybe there's a question that you didn't study for, but your notes contain the answer, then you can retrieve the relevant information to be able to provide an adequate answer to that input query, right? So that's a good way of kind of visualizing what RAG itself is at a high level. Now, within an actual RAG workflow, this is obviously a lot more complicated than the way I just painted it out there. There's many different moving parts. So when I talk of RAG, there's a few different things that we should become familiar with. One, there's the prompt, which is the input query. So just like you might ask or invoke any LLM, there's still an input query in terms of what you might be working with. Two, there's the LLM that does the inference itself. So this is the one that answers the prompt and takes whatever other kind of context provided by your corpus that you might be working with, and gives a final output. This is kind of the natural language output that's generated in that. And then three, this is the actual corpus or knowledge base. That's also another way of imagining it or visualizing it. And these are the documents that have that additional context. So whatever other information you want your LLM to be able to retrieve from or pull from to augment that input prompt, it's all contained within this corpus or knowledge base. So if you don't have a good corpus or knowledge base or set of documents, then this doesn't really make sense for putting together a RAG workflow. Now, four, right? I talked about how the input prompt comes in. Once the input prompt comes in, how do we compare it to the corpus or knowledge base that we have pre-existing? Because we can't just compare text to text. All ML models, as we talked about, right, they require kind of vector representations for them to be able to compare and understand these. Because all ML models at the end, they are just math at a very high level. These are just different mathematical functions that are essentially implementing these models underneath the hood. And that's why we can't process text directly. We need a vector or numerical representation of what that text might look like. And that's where there's actually a second model in this entire RAG workflow known as the embeddings model. And what this does is it converts your text into vectors that you can then compare or have your models understand better, right? So this embeddings model is really kind of when that prompt comes in, it will convert it into a vector format. And also asynchronously, there's two things it does, right? It also converts your existing knowledge base or corpus you passed in into embeddings or vector representation as well. So that way you can actually compare the input prompt to whatever you already have pre-existing within your corpus. Now, all this stuff, these vectors that we talked about being generated for this knowledge base or corpus, right? We need a place to store it. And that's where something known as a vector store comes into play. And this houses all these embeddings of the corpus that you might be working with. So you might have, for example, your knowledge base, like locally or let's say within S3, a stored service on the AWS cloud. What the vector store does is you can take, once you've ran your embeddings model across this corpus, you can push it to a vector store essentially, which houses all these different embeddings that we're talking of. And the key part is there's two functionalities. It doesn't just house these embeddings, it also does the retrieval portion of this RAG workflow. So when we have a input coming in, right? We have an input prompt coming in. Let's say our embeddings model converts it to like 000, like that vector format there. We then want to be able to compare it to see what are the other different similar vectors that exist. And there's different algorithms for this, such as k-nearest neighbors, where you can essentially see what are the closest or most similar kind of textual representations or vector representations to the input prompt that was passed in. And you can select, essentially, you can tell your vector store and the retrieval engine within it, hey, retrieve the top 5 similar documents and augment my prompt with this. And with this additional information now, give me a better output that essentially exists. And this is where we will then see a final output, which is much better than what we might have had if we didn't have this vector store, this additional information that populated it right there. So these are the different moving pieces that you want to become familiar with. And I've also drawn this out in a bit of a diagram so you can understand this better. But this is the same workflow that I'm talking about, right? So step one, we'll have this user input, this prompt template or prompt that you're passing in. What we do is asynchronously, we also have this knowledge base right here. And this embeddings model has converted all of these documents into vector representations and pushed it to the vector store. And then this vector store also, like I said, it also serves, sorry, didn't mean to move that there. It also serves as the retrieval engine, depending on the vector store you're working with. There's different ways this might be presented to retrieve the relevant documents. So this embeddings model in real time will convert the input into an embeddings, but also keep in mind asynchronously beforehand, it's taken your knowledge base or different documents and converted them into embeddings also and pushed it to the vector store. So once we have this relevant information retrieved, we can then augment and pass it into our LLM, right? Which is our whichever LLM of choice we have for inference, and we get our natural language output that you're working with. So this right here is really your study guide or kind of analogy that we were talking of. The vector store is the vector representation of it and the way you retrieve the relevant kind of documents that exist. So really, that's kind of the way you can visualize end-to-end workflow. And there's obviously optimizations that can happen here at each level that we won't really get into in this video, but you can imagine this is all the moving parts coming together here in terms of it. Now for the stack, right? I'll actually just return here. There's different things that you can use for each of these different moving parts. There's different options that exist both at the enterprise and open source kind of level for it. For our LLM inference, the model itself here, we'll use Amazon Bedrock and we'll use Claude via it. You can use any kind of LLM that you're comfortable with. But within Bedrock, we have this fully managed kind of model offering serverless model integration, right? With these different model families. So it's pretty easy to use, but you can use whatever you're comfortable with here. And then for our knowledge base, I'll do this locally within the notebook instance that we're going to be working in. But you can also have this in something such as S3 and read from there, especially if you have a large list of documents, unlike just the sample POC we'll look at here. The embeddings model will also use Bedrock, which comes with support for different embeddings models, and Titan is the one specifically within Amazon that exists. So we'll just use that as embeddings model, but like I said, you're not constrained to it. If you have an open source Hugging Face embeddings model that you might want to work with, you can use that as well there. And for the vector store, I'm actually going to use a open source one from Meta known as Face. And like I said, you can scale any of these as you want, and you can pick your own ones that you're comfortable with. I picked the ones that are simplest here for this use case. But like I said, there's different options that exist. For vector source especially, there's many enterprise level solutions such as Pinecone DB and more that you can use that are completely managed kind of offerings around it. There's also OpenSearch within AWS as well. So really up to you. You can benchmark and test different ones as you get to a production environment or setting within this. But that at a high level is our stack, right? And now the key part is these are many different moving parts. We really need one framework that will kind of bring all of this together into one kind of encapsulated object, while also having all these having constructs for all these different moving pieces. And that's where LangChain becomes really, really helpful, because there's constructs, kind of like I was saying, for these Gen AI pieces that we're talking of. And what I mean by this is and I'm completely butchering spelling here as always, but what I mean for this here is there's objects that are defined for prompts, for example. There are objects that are defined for vector stores. There's objects that are defined for different model providers, such as Bedrock, OpenAI, and more. And most importantly, you can encapsulate all these. There's managed objects for RAG. So there's chains that are tailored for RAG workflows where you can stitch together all these different objects. Then also for agents, which we'll explore in coming videos, where there's different things such as React-based agents where that's already implemented for you. So really the beautiful part about LangChain is there's predefined objects for all these constructs that you'll see over and over within Gen AI applications. And it brings all these together into a singular chain depending on your use case. So it could be a RAG-based chain, it could be an agent that you're defining. All these are predefined for you within LangChain, so it brings you a very neat kind of unified way of bringing it all together. Another good part about it is there's built-in support for many different model providers and many different vector store. So we'll see there's a managed face object. We'll see there's a managed Bedrock object. There's really many different providers and vector stores where it's kind of agnostic and provides the interfaces for each of these so you can simply import them without having to kind of define your own custom logic there. So there's widespread OSS support there in terms of that. So at a high level, before we get hands-on, just think of LangChain as the orchestration framework that really gives you a unified way of working with many of these different services and features. And if this doesn't make sense yet, don't worry. What I'm going to do now is I'm going to get out of this screen and I'm going to go into our console as always in AWS. And right now I'm working within a SageMaker AI notebook instance, T3 medium instance right here. You can also do this locally if you would like to within your own environment, um, as long as you have access to Bedrock and you're able to install these different Python libraries here. But you can see here, I'm just going to work in this notebook instance, but obviously adjust this depending on your use case, depending on how many documents you have, wherever else you might be working in. But if I go into this environment here, let's kind of bring to life or explain some of these different moving portions that we were talking about. What I'm going to do, the sample problem that we're going to be tackling, and this is a bit of self-plug, I guess, is I have a bunch of different SageMaker articles that I wrote back when I used to write on Medium. These are all kind of high-level concepts or lower-level concepts, sorry, about different SageMaker parts. And there's very specific guidelines here in terms of very low-level details that an LLM might not have been trained on, especially because some of these were newer features that just got recently launched. I've attached all these documents in their PDF format locally within this notebook instance. Like I said, you can also do this within S3 or depending on the environment you're working in, just pick the appropriate source for you. Just keep in mind as you scale this up, as these numbers of documents increase, you want to be aware of that depending on where you're storing them. But I've essentially have them locally here within this instance's memory right here, these SageMaker articles. What I want to do is I want to see how well an LLM does without access to these articles versus giving access to these articles via a RAG workflow. And I'm going to ask it some very nitty-gritty SageMaker questions that has the answers within these articles that I've written here, essentially. You can obviously replace this with whatever all relevant documents of yours for your use case or POC. So if you have a very niche use case where it's personalized documents for yourself, you can replace this kind of directory here with that. Now in this notebook, I'm going to install LangChain face CPU that I'm working with. This is a CPU-based instance, so I'm installing that for a GPU environment, which you don't need for this example at least. Make sure you install face GPU there. Install LangChain and install PyPDF, which is a way to essentially work with my PDF documents. And I install that here within my environment. And next, what I'm going to do is I just want to play around with Bedrock real quick. We'll get to each of these different imports specifically in a second. I would just want to play with Bedrock a little. I'm going to use Claude as my model. We're using V2 here, but you can use the 3.x family. Those are also supported now. But I just want to understand what a sample kind of API call looks like, just so I can understand what the prompt template looks like here. So I've sent in a sample request. I now understand how Bedrock Claude, I can essentially invoke it using that Boto 3 API client that I have right there. Next, we should actually get to setting up all these different moving portions that we were talking about. And that includes the embeddings model. So I have my articles here locally. This is my corpus or knowledge base. I need my embeddings model to convert this into a numerical or vector format. And like I said, Face, the open source implementation by Meta, is the one that I'm going to be using to store these embeddings. So now from LangChain, there's a few different things I'm going to be importing. From the embeddings, I'm going to import Bedrock embeddings, and from LLMs, I'm going to import Bedrock. Now this is key, right? Like I said, LangChain comes with different constructs or objects for all these different popular ones we might be working with. This embeddings import, I'm saying I'm going to be working with Amazon Bedrock for the embeddings model. And the model that I'm going to be defining, I'm saying the model provider is Bedrock once again. And you can see this here, because essentially what I do is I'm going to say, hey, the LLM, this is the LLM that's going to be conducting inference. This is going to be Anthropic Claude V2, that's the model ID, just like we invoked it up here in terms of what we're working with. And I'm going to pass in any different arguments that I might also have within this, any tokens, any kind of parameters that you want to experiment with. But this is my LLM for inference. This is the object, and you can see it's very simply defined through LangChain. The second model that I'm going to be working with is our embeddings model itself. And for this, I want to use Titan specifically. Titan is the embeddings model within Bedrock that I'm going to be working with. And as I defined, I'm going to be using this Bedrock embeddings model that I'll be working with here. And these are my two different model objects. And you can see it's very, very simple within LangChain to be able to kind of pick the model provider that you might be working with or the embeddings model you might be working with, both of which are Bedrock in this case. The next thing I do is I'm going to say, I want to store our embeddings in this local directory here. And what I'm going to do is I'm going to use some LangChain's other kind of utility functions to load this data. So this PyPDF directory loader right here parses my PDF documents here and essentially loads our data. And we say that this is a PDF document. And the reason LangChain's handy once again here is for common data formats such as PDF, it will automatically parse and pick up on this. So that's why we installed PyPDF earlier, if you remember, because this makes it very easy to extract text from those types of documents. So there's support across different data loaders or different formats that you might be working with. And that's what we imported right here for document loaders. So if you have CSV or text, you can import that necessary or kind of corresponding loader here and parse it for the text data that we're going to be working with. Now, once we've kind of done that, we'll load and split the documents, just chunk them essentially because we can't process all of them at once. And what we do here is we pass in the vector store that we're going to be working with. So we're saying here in this cache, this is where everything's going to be. I already ran this, so you won't see it as soon as until we run the next cell. But here in this embedder, we're essentially saying here's our embeddings model we're working with. Here's the vector store for where everything is going to be pushed. And then the next part that we're working with here is, right, this vector store itself, we're going to say, hey, face is what we're working with. And the documents are these different pages that we just loaded up from the PDF. And the embedder is essentially where we're going to be passing this in here, which is this cache that we're working, this cache kind of directory that we're working with. So if I go up here, you'll see these same imports here once again. You'll see for LangChain.vector source, face is a supported vector store, and you can import the one that you might be working with there as well. And now if I scroll down, all these different moving parts, right? Once I run this vector store kind of, when I instantiate this vector store here, this cache directory is going to get populated with all the different embeddings that are essentially representing the initial corpus that I passed in with these SageMaker articles. Now that we have our vector store set up and we know what our LLM for inference is, and we've kind of created embeddings asynchronously, like I said, for our existing corpus that we have, we can now move into bringing all this together into a singular chain where we can essentially have our RAG workflow. What I'm going to do here is I'm just going to define a bit of a sample prompt. This is the prompt that we were looking at earlier in terms of what's expected for Bedrock itself. And what I'm going to do is I'm going to structure any input queries into that format for Claude. And the most important part is this final step here. So from LangChain.chains, I'm going to import retrieval QA, and I'll link this documentation down below too. This retrieval QA, we're essentially saying this is a RAG-based workflow where we're going to have a LLM for inference, but we also have a vector store as the retriever. So in our vector store, we have our different kind of embeddings that we've generated from that existing corpus. And what I'm going to do is I'm going to define this as a singular chain. And a few flags that I enable here is return source documents. I want to know what are the relevant documents we got the context from. So I enable that flag there essentially. And then I can pass in a bunch of different prompts. And before we get to inference here, I want to emphasize how important it is just to understand this is really what brings together all these moving pieces. So if we kind of revisit what we were talking about, we have our vector surface, we have our different model objects that we define, right? Here within this cell. And this embeddings model essentially generated the embeddings for the vector store. And that's where we essentially populated it using funds, right? In this case, as a vector store of choice. And this here has been stitched together end to end into a singular chain that you can work with. And now if we run these sample prompts, right, we'll see that the RAG workflow that we have, so I have two different things that I'm iterating over here. One, I'm just going to invoke this model in a vanilla format using just the Boda 3 Bedrock API client that we defined earlier. And then I'm actually going to run my RAG chain here itself. And I want to see what the different outputs look like for both of these options. So here in this case, no RAG, just the vanilla Bedrock kind of response. I asked, what does Ron Big Roger write about? And you can see here, the model does not know because it's not been trained on this data and it doesn't have access to this data. Now, if I run a RAG-enabled response, where there's more context provided, you can see based on the context provided, it seems like Ron writes articles about SageMaker and related AWS services. So with that context, we're able to answer this much, much better. And you can see the same thing. You can see that the foundation model does pretty well with something like what is Amazon SageMaker, because it has existing information and knowledge and understanding of it. But if we get to the deeper, lower level questions, right? For example, the nitty gritty stuff, and you don't need to understand this, but like what's the difference between MME and MCE? You'll see that the model, or sorry, the foundation model without this extra context from the articles itself does not provide too good of a response there and kind of gives the wrong output. So the key part here is, right, with the context that we were able to derive from a RAG workflow, and that's where you can see these return source documents as well to understand where it got this additional context, we're able to give a better response essentially because we have additional information which we know contains kind of the right answers, the right information, or knowledge for us to be able to answer the questions that are coming in. So at a high level, what you want to take away from this, right, as a bit of a recap, I know we dumped a lot, is LangChain really brings together all the different moving parts together, but at an essence, within RAG, you really want to use it when you know you have a corpus that you can retrieve kind of the right information from to really augment any input questions for your GenAI application itself. So that's the main takeaway from here. You don't need to use Bedrock. You don't need to use any of the different kind of stacks such as Face that we used here, but understand the functionality of each. Within Bedrock, we have the embeddings model via Titan. We have the LLM inference model via Claude. Within Face, we have our vector store, which stores our embeddings and also serves as a retriever to return the relevant information depending on the input prompt that's coming in. So any similar embeddings compared to the input prompt that's coming in, that's where Face, the magic happens. And LangChain really provides all the utilities for these common objects or constructs within GenAI and really manages to encapsulate it into a single workflow that you could work with. And there's a lot of different utilities within it, right? As we saw, where there's support for many different kind of open source models or different model providers. And then there's also a lot of utilities for working with data such as PDFs or common operations that might happen in the GenAI space itself. So I hope that was a useful introduction or useful kind of guide in terms of how you can integrate these two popular tools. What we'll do in coming videos is we'll continue to explore different LangChain capabilities and also continue to use Amazon Bedrock and other model providers to see how we can build some more real world GenAI kind of applications or use cases that you can work with. So thank you as always for watching. Any questions or feedback, feel free to leave in the comments. And if you have any doubts, feel free to reach out individually as well via LinkedIn or Twitter. If you like this video, feel free to leave a like and subscribe as always. And thank you, and I will be back very, very soon.